In this video, I will demonstrate how to do the 3.2 homework problems on WebWork. In section 3.2, we're studying quadratic functions, and this first problem says to find the vertex of the parabola defined by the function f of x equals x squared plus 4x. So the vertex is the turning point of the parabola, and we know how to find the formula for the vertex. It always occurs when x equals negative b over 2a. Alright, in number 1 we have f of x equals x squared plus 4x, and we know that a quadratic function in standard form looks like ax squared plus bx plus c. So in this function, the leading coefficient a would be 1, because you have 1x squared, and b is going to be the coefficient of x, which is 4. And we know that the vertex occurs when the x coordinate is negative b over 2a. So for this function, we get the negative of 4 divided by 2 times 1, which gives us negative 4 over 2, and that reduces to negative 2. So the vertex is going to occur when the x coordinate is negative 2. To find the y coordinate, we plug in negative 2 into the function, and we get negative 2 squared plus 4 times negative 2, which equals 4 minus 8, which is negative 4. So the x coordinate of the vertex is negative 2, the y coordinate is negative 4. So when written in coordinate form, it looks like negative 2 comma negative 4. Now let's move on to problem 2. We have another problem where we have to find the vertex of a parabola, and we're going to use the same formula that the vertex occurs when the x coordinate is negative b over 2a. In problem 2, we have f of x equals negative 5x squared plus 4x plus 1. The leading coefficient a is negative 5. The middle coefficient is 4. b is 4. So again, the vertex occurs when x is negative b over 2a. So we get negative 4 over 2 times negative 5, which reduces to negative 4 over negative 10. And that simplifies to 2/5. So the x coordinate of the vertex is 2/5. Again, to find the y coordinate, we would plug in 2/5 into the function. This would give negative 5 times 2/5 squared plus 4 times 2/5 plus 1. And when we multiply this all out and simplify, this will reduce to 9/5. So the vertex has coordinates 2/5 comma 9/5. So when I enter my answer, I can write it as 2/5 comma 9/5. You could also write this in decimal form as 0.4 and 1.8. Let's go on to problem 3. In problem 3, we also have to find the vertex, but then we're going to find the intercepts, the x-intercepts and the y-intercepts. We can start by finding the y-intercept very quickly. This is still the constant term of the expression. So the y-intercept is at y equals negative 14. Let's work out the vertex and the x-intercepts now. So for this function, the leading coefficient is 1, the middle coefficient is negative 5. So again, the vertex occurs at negative b over 2a. So when b is negative 5, we get the negative of negative 5 divided by 2 times 1. So this gives me an x coordinate of 5/2. The y coordinate of the vertex would be found by plugging in 5/2 into the function. So this gives 5/2 squared minus 5 times 5/2 minus 14. And when we simplify this expression, we get negative 81 over 4. So the vertex has coordinates 5/2, negative 81 over 4. And then we also had to find the x-intercepts. To find the x-intercepts, we solve f of x equals 0. So we set the function equal to 0 and solve for the inputs x that gives an output of 0. So to solve this quadratic equation, we set x squared minus 5x minus 14 equal to 0. If this is a factorable trinomial, then that's definitely the way to go. So when I look at this expression, if it's going to factor nicely, it'll factor as the product of two binomials. So we're doing the opposite of the multiplying, the opposite of the FOIL method. So the first term times the first term will be x squared. So know that the first terms of each of these factors would be x. Now this is going to be factorable if I can find two numbers that multiply to minus 14 and add to minus 5. So can I find two numbers that multiply to minus 14 and add to minus 5? Well, the numbers minus 7 and plus 2 would work. Negative 7 times 2 is 14. Negative 7 plus 2 is negative 5. So I can fill in the rest of the factors with a minus 7 and a plus 2. So I factored this trinomial. The reason why it's nice to have it in a factored form is because if a product equals 0, then by the zero product property, we can set each factor equal to 0. The only way x minus 7 times x plus 2 could equal 0 is if one or both of the factors equals 0. And then solving, we can add 7 to both sides to get x equals 7, subtract 2 from both sides to get x equals negative 2. So here are the x-intercepts of the function. And we said that the constant term minus 14 is the y-intercept of the function. When I go back to problem 3, I can enter my vertex as 5 halves, 5 over 2, and the y-coordinate is negative 81 over 4. And then the x-intercepts are at 7 and negative 2. And I can separate them with a comma. Now let's move on to problem number 4. In problem number 4, we're asked to solve this quadratic equation. So this would simulate finding the x-intercepts of this polynomial function, this quadratic function. Now we see that in the last problem where we could factor this trinomial, we can't factor this trinomial because you can't find two nice integers that multiply to negative 4 and add to negative 8. So we're going to have to use the quadratic formula to solve problem number 4. So in this problem, we're going to have to use the quadratic formula, which gives a solution to any quadratic equation where the leading coefficient is a, the middle coefficient is b, and the constant term is c. So we have a equals 1, b equals negative 8, and c equals negative 4. So when I substitute in this expression, the negative of b will be the negative of negative 8 plus and minus the square root of b squared. So be careful to put parentheses around the negative 8. Negative 8, the quantity squared, minus 4 times 1 times minus 4. All divided by 2 times 1. So we're going to simplify this expression. We have the negative of negative 8 is 8, plus or minus the square root of negative 8 squared is 64. Negative 4 times 1 times negative 4 is positive 16. All over 2. And so one correct solution, if I simplify one more step, 8 plus or minus the square root of 64 plus 16 is 80 over 2. This would actually be a correct solution. So we would enter both answers as 8 plus square root of 80 divided by 2, and then comma 8 minus square root of 80 divided by 2. However, the number 80 has a factor that is a perfect square. The number 80 is square root of 16. 80 is 16 times 5. So I can simplify this by thinking of square root of 80 as the square root of 16 times the square root of 5. And then the square root of 16 is 4. And so this can further be simplified because both factors in the numerator have a factor of 2. And so if I cancel a common factor of 2 in the numerator and denominator, this would simplify to 4 plus or minus 2 square root of 5. So this would be a simplified answer, but actually the first answer we got would also be correct in WebWork. So back in WebWork, we can enter our answers as 8 plus or minus square root of 80 over 2. We can do that by doing parentheses 8 plus square root of 80, and then putting parentheses around the whole numerator, dividing that by 2, and then doing the same expression with a negative sign in front of the square root. So 8 minus square root of 80 all over 2, and that would give us a correct answer. And as I said, we can actually enter our simplified answer too. So that would be 4 plus 2 square root of 5 and 4 minus 2 square root of 5. Those would also be correct solutions. You can actually enter your answers in decimal forms as well, but be careful to carry out several decimal places. So you can see in the solution here, 8.47214. So carrying out 5 decimal places when we do, so we don't have any rounding errors. Let's look at problem number 5 now. Problem number 5, we have another quadratic function, and we're asked to find the intercepts, the y-intercept and the x-intercept. The y-intercept is equal to the constant term, so y equals minus 100 is the solution. Now to find the x-intercepts, we're going to have to set the function equal to 0 and solve for x. This is not a factorable quadratic polynomial, so we're going to have to use the quadratic formula again to find the x-intercepts. So for our quadratic function number 5, we know that the y-intercept equals the constant term, minus 100. To find the x-intercept, we set the function equal to 0 and solve for x. Now, I notice that we can do some factoring. There is a common factor of 2 on all 3 terms. To make all the calculations simpler, I'm going to divide each term by 2. And because 0 divided by 2 is still 0, so I can get this reduced expression, x squared plus 14x minus 50 equals 0. And again, this is not a factorable trinomial because you can't find 2 nice integers that multiply to minus 50 and add to minus 14. So we're going to have to bust out the quadratic formula again. Here the coefficients a are going to be, I'm going to use 1 for a, 14 for b, and negative 50 for c. We could have just used the original coefficients, but all the expression would have an extra factor of 2, and would make calculations a little bit harder. So I have the negative of 14 plus or minus the square root of 14 squared minus 4 times 1 times minus 50, all divided by 2 times 1. When I simplify this expression, I get minus 14 plus or minus the square root of 14 squared, which is 196, minus 4 times minus 50 is positive 200, all divided by 2. And so this, one way to write this would be minus 14 plus or minus the square root of 396 all over 2. Now this would be a correct solution, but just like the last problem, we can simplify this a little bit because the square root of 396 would be equal to the square root of 36 times square root of 11. So we could simplify this expression as minus 14 plus or minus the square root of 36 is 6, so it would be plus or minus 6 square root of 11 over 2. And when I cancel a common factor of 2 in the numerator and denominator, I would get minus 7 plus or minus 3 square root of 11. Again, you could also type in the expressions in your calculator to get the decimal values. So when I go back to WebWork to enter my x-intercepts, I'm going to enter them. I'm going to use the simplified form of minus 7 plus 3 square root of 11 and negative 7 minus 3 times the square root of 11. Remember to separate them by a comma. And if you're using the unsimplified form, make sure you put a parentheses around the whole numerator. And if you want to just enter the decimal answers, you can do that as well. Okay, moving on to problem number 6. In this problem, we have a word problem that uses our knowledge of quadratic functions to find the solution. Notice that in the problem it says to build a rectangular pen that encloses the maximum area. So when we see this word maximum, we're reminded that for quadratic functions, the maximum value would occur for a parabola opening down. The maximum occurs at a vertex. So when we see over the next 3 problems, when words like maximum or minimum, these are telling us that we're going to have to set up a quadratic function and find the vertex. So we have to build 2 rectangular pens that are next to each other and they share a side, and we have 420 feet of fencing to do this. We're going to find the dimensions of each pen that can enclose the maximum area. Now, for a rectangular pen, we have 2 dimensions, a length and a width. We're going to use the length to be the length of the side that has where the wall that they share together. So let's draw a picture and solve this. So for problem number 6, here's the situation. We have 2 rectangular pens with a length and a width, and they're sharing one length. And we have a total of 420 feet of fencing to do this. Well, from this diagram, we see that we have 3 lengths and 4 widths total for this construction of this pen. So with 420 feet of fencing, we have to make all those dimensions. So the 420 feet is going to be equal to 4 widths plus 3 lengths. So this is an important kind of a perimeter expression that we're going to use, because we're going to try to maximize the area of each pen. Well, the area of a pen is just length times width. So from the area formula for a rectangle, area equals length times width, you can't maximize this because we have 2 different variables. So we're going to use our perimeter expression to replace one of these variables, and when we do that, we'll end up with a quadratic function for the area. So if I look at this perimeter expression and I solve for W, we see that if I subtract 3L from both sides and then divide both sides by 4, we'd get 420 minus 3L divided by 4 is W. And I can simplify this a little bit maybe with 420 divided by 4 is 105, and then minus 3/4 L. So from this expression, I can now use the substitution step here, and I can replace W with 105 minus 3/4 times L, times the length. So when I substitute this in for W, we get L times this expression, and when I multiply that out, I get an honest to goodness quadratic function. So L times minus 3/4 L would be minus 3/4 L squared. L times 105 is plus 105 L. So now we can maximize this area function by we know where the maximum occurs. The maximum will occur when the variable is negative b over 2a. So using, like we found the vertex earlier, so the b is negative 105, the a is negative 3/4, So negative 105 divided by 2 times negative 3/4. When you simplify this, you get 70 feet. So the maximum occurs when the length is 70 feet. And to find the width that maximizes the area, we can use this expression, 105 minus 3/4 times the length, which is 70. And this simplifies to 52.5 feet. So that is the width that maximizes the area. Now, we also are asked to find the maximum area. Well, the maximum area will occur when you use these dimensions. So it's 70 feet times 52.5 feet, and that will give us 3,675 square feet. And now it's important that you note that these are units of measurement, and you have to actually include these units of measurement with your final answers in web work. So back in web work, the length of each pen along the wall that they share should be 70 feet. And you have to write FT for feet. And the width is 52.5 feet. And the maximum area is 3,675 square feet. So we put feet to the power 2 for square feet. All right. So now let's look at problem number 7. Problem number 7, we're given a formula for the height in feet of a ball that's thrown by a child. So this expression gives us the height of the ball, where x is the horizontal distance in feet from the point at which the ball is thrown. So imagine you have a child throwing a ball, and depending on how far out the ball is, we can use that distance, the horizontal distance x, to determine the height y. So the first part says, how high is the ball when it leaves the child's hand? So that would be the height when the ball is 0 feet from the child. So we need to find y when x equals 0. This is another way of asking us, what is the y-intercept for this graph? When you plug in 0 for x, this term will be 0 and the middle term will be 0, so you just get the constant term, 3. So the ball was 3 feet high when it left the child's hand. We're asked, what is the maximum height of the ball? So this is a parabola. This will occur at the vertex. We need to find the height of the vertex for part B, and we also need to answer how far from the child does the ball strike the ground. We're going to use the fact that the ground level is always defined as height 0. So if the y-coordinate is 0, we're solving a quadratic equation. In other words, we're finding the x-intercepts for part C. So for this function in number 7, we know that the maximum will occur when x is negative b over 2a. So b is 4. So we get the negative of 4 divided by 2 times negative 1/12. So this simplifies to 24 feet. And this is how far out the ball is. So the ball is going up and then landing down the ground. So the vertex occurs when x equals 24 feet. We need to find the height of the vertex. So the height is the y-coordinate when x is 24. So we get negative 1/12 times 24 squared plus 4 times 24 plus 3. And when we simplify this expression, we'll get 51 feet. So this is the maximum height of the ball. So this was the answer for part B. Now for part C, we have to see when the ball hits the ground. Okay? And so in order to do that, we need to set the function equal to 0. So negative 1/12 x squared plus 4x plus 3 equals 0. So this is not a factorable quadratic function. So we're going to use the quadratic formula again with a equals negative 1/12, b equals 4, and c equals 3. So x will equal the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, you would get two solutions to this expression, but there's only one time when the ball hits the ground, and it's going to be a positive value for an x-intercept. So when I look at this expression, the way this fraction will be positive is if the numerator is negative, because the denominator is already negative. So this minus 4 minus this expression divided by this, that's actually going to be the solution that I want. So negative 4 minus this expression is going to be square root of 17 all over 2 times minus 1/12 is minus 1/6. And this expression, when I type this into a calculator, it's going to be equal to 48.7386. So that would be the distance when the ball hits the ground. In this case, it's good to have a decimal value for this expression. Back in web work, we saw that the maximum height was at 51 feet, and the word for the dimension of feet is already put in here. And how far from the child does the ball strike the ground? 48.7386. So rounding to 4 decimal places should give us enough precision to get the correct answer. There we go. Now, in the final problem, number 8, we have a revenue function. The revenue function R gives us the revenue in terms of the number of units sold, X, where R is the total revenue in dollars. Find the number of units sold, X, that produces a maximum revenue. But this is just finding a vertex of a quadratic function. So for number 8, I rewrote the leading term first. So we see that A is negative 0.4 and B is 260. So the maximum occurs when X is negative B over 2A. So that would equal negative 260 divided by negative 2 times negative 0.4. And this equals 325 units. So the maximum occurs when they sell 325 units. The maximum revenue is when I plug in 325 for X and this expression equals $42,250. So this is your maximum revenue for selling 325 units. So in web work, I enter 325 for X, 42,250 for the maximum revenue, submit, and we get the correct answer. So this finishes up section 3.2 homework.